everyone. Thanks for coming. On behalf of We Forum Group and Monmouth Medical Center, thank you for joining us for Dr. Oscar Coetzee's lecture, Genetics and Health, What Your DNA Cannot Tell You About Your Path to Health. Just two brief reminders. We ask that you kindly silence your cell phones before we begin. There will be a brief question and answer session at the conclusion of this lecture. In an effort to begin our keynote luncheon that will begin promptly after this lecture, please make your way into our banquet hall and take your seats. Now it's my pleasure to introduce our esteemed speaker, Dr. Oscar Coetzee.
Thank you for the invite. Let me just give you a quick disclosure here. For those of you that are intimidated by this lecture, I'm not a geneticist or a genetic graduate. I'm a clinical nutritionist that uses some of the genetic information at hand nowadays to really dig into clinical cases. So I'm not going to make this at the level of genetics, which is probably why some people feel intimidated by the topic. But that's not the way we do it in clinical practice. Okay, so I'm going to discuss a couple of things about general topics about misunderstandings, disconnections about the reality of genetics and what it means and what's an epigenetic and what's a genetic association to changes in a person's health, which is something that is really coming to the forefront. I'm sure that you guys have heard somebody speak earlier today about the kind of biome at some particular point. And that's an area that we are only now starting to kind of get an understanding of what it really does. You know, there's 5,000 species of fungi, there's 300 species of parasites, there's 2,000 species of bacteria that we just don't know how they interact with each other and how they communicate through our bodies through our genetic pathways. So what I'm going to show you today, and I'm going to give you an example of a particular case study that I'm working at the moment on with a very brand new disease or a condition called lipedema, where I'll show you how we dig into the genetic components of an individual to find out what diet is best for them and what exercise protocol would be best for them, so that we can all get away from this crazy notion that calories in, calories out is the way to do anything. We all wear different size shoes, therefore we all need to be slightly different in the way we approach things. And being in clinical practice for 20 years like I have been, I've made mistakes too. We've given everybody consistently the same supplementation. We've given people the same dietary intervention, only to find out many years later that some people don't react well to certain diets. And as you guys well know, there's a lot of fad stuff going on at the moment, right? There's a lot of talk about ketogenic diets, and there's a lot of talk about anti-inflammatory paleo diets and anti-inflammatory diets. What does that really mean? What does that really mean to the individual? And every single person here might do okay in the initial phases on those individual intervention protocols, but as a general rule, you need to get more specific, right? Because we all have genetics, we all have genes, we all have an environment around the gene that can be switched on and off. So when people come to me to do a genetic evaluation, it's a nutritional genomic understanding, okay? So what it really means is I tell you what your strengths are in your body, and I tell you what your weaknesses are in your body. And a lot of people come into with the attitude, and I don't want to know what my bad genes are. No, you actually do, because once you find out what your bad genes are, you can realize what we can do to not switch them on. You understand? Or prevent them from becoming a problem. And the example that I would like to give you, let's say we all go on a standard American diet, right? And we're all eating the same foods. Let's say you have a genetic predisposition to have a weakened, inherently weakened kidney system, and you have a heart, and you have a liver. If we're all on the same protocol, whatever your genetic inherent weakness is where the disease will find its way. You understand? So we all respond differently to those particular genes, even though the same diet can do damage. Does that make sense to everybody? All right, so a little bit about me. Like I said, I've been in clinical practice for 20 years. I practice with Dr. James Prudian in Long Branch, New Jersey. I see one or two of my patients here, which is good. And what we do there is pretty much a all-integrative practice. Okay, we have acupuncture, nutritionist, we have a medical doctor that we refer people to in and out. We have massage therapy and chiropractic, and also neurological associations to the chiropractic division. My specialization is clearly the nutritional stuff. I've specialized for many, many years in metabolic syndrome, diabetes, weight loss resistance, and right now I'm strongly working on research in intestinal permeability, or what people perceive as something called leaky gut, which is one of the terms I hate more than anything because it sounds like a leaky gut. Intestinal permeability. So I'm working on different protocols to understand it through the genetic understanding of individuals. I also wanted to understand that there is a massive human element, right, in every single one of us. So not everything is just a gene. But it's interesting because those genes can also tell us how our neurological pathways and obsessions can be associated with genes, right? So I want to make sure you understand that when a person comes into my office, they are not a number on a gene pool or a symbol, okay? It's actually a little bit more than that. I'm a professor involved with kind of various schools at the moment. I teach at Maryland University of Integrative Health, where I'm an associate professor in the clinical department for nutrition. I just took on a position at Georgetown. They're actually evolving their medical school to add in nutrition for the first time in their medical curriculum, which is really cool. We're designing some courses for them there. And I'm the associate director of the Doctoral of Health Sciences course at the University of Bridgeport. So I'm very involved with the academic part of it, I'm very involved with the research part of it, and the publications as it relates to our field. All right, so I really want to talk about nutrigenomics and nutritional medicine because everybody is always talking and talking about that consistently now. You know, what is nutritional medicine? You know, is there such a thing as nutritional medicine? What is nutrigenomics? What is genetics? So basically what this means is what information is in food to talk to your cells, and how do those cells respond to that information in food? Now this is a very straightforward statement to make because it's not what the food does, because we can say that a food contains a phytochemical or a phytonutrient or some enzyme or whatever that catalyzes a reaction. But if you're not absorbing that nutrient, it's meaningless, you know, of what it actually does for the human system. So what we need to dig into is, are there certain genes in an individual that can make them potentially malabsorb magnesium? Or that they don't do very well with folic acid or vitamin B12 because of some sort of an MTHFR mutation? Do they have an issue with vitamin D through a VDR receptor? You know, we need to look at those things, because sometimes people can come into your office and the vitamin D levels are low, and you keep pumping them full of vitamin D and the vitamin D is not moving. You need to find out if there's some sort of a genetic association, right? And maybe the answer to that is not a supplemental vitamin D intake, maybe there's something else that we can do in a better form of absorbable vitamin D, and to determine if that person maybe doesn't have an issue having slightly low vitamin D. You know, we've all assumed that if we look at blood work, that if a person is between 30 and 100 on a vitamin D level on blood work, that they're low at 929. How about people that I've seen that show all the symptomology of vitamin D deficiency at 39? And some people have no symptomology of vitamin D deficiency at 27. We need to start looking at these things, because if a person has a genetic predisposition for vitamin D not being uptaken as aggressively as it should, maybe there's a reason for that, right? These things don't, always just remember one thing, that the human body is not designed to hurt you. You understand? Your human body didn't deliberately decide, hey, I want to give you less opportunity to absorb vitamin D than her because I don't like you. Right? There's reasons, evolvement. Maybe you lived in an area genetically predisposed for hundreds and thousands of years where people were exposed to sunshine and you guys didn't evolve the uptake of vitamin D. Who knows, right? But it's very interesting to see that people actually have these genetic defects or interruptions that you would think, man, why would the body even decide to do something like that? You know, it's crazy for the body to jump into something to that effect. Go to the next one. All right, so here's always a statement that I like for people to know. So if you have seen more than 4 medical specialists for a chronic condition with no positive outcome, then nutrition might be the medical answer, right? And that is something that is actually pretty profound statement to make. In clinical practice, in the last 20 years, I've seen miracles in people, right? I've seen diabetes reversals, I have seen stagnation in certain horrific conditions, and there are some very complicated cases that takes a long time to kind of figure out. But the power of nutrition is actually coming to light now, because if you tie the gut biome and what the gut biome does from the foods that you eat and how those biota communicate back to your cells on a genetic level, you'll start to understand why food is so powerful. Because 7 to 10 to 12 years ago, I designed a protocol to reverse metabolic syndrome, pre-diabetes, and we did very well with it. Various dietary interventions. And then we started seeing that these people's eczema started to improve, skin conditions started to improve, they started to lose weight. Because when I designed these guys, I didn't design them for weight loss specifically. I designed them for health rejuvenation. And just the understanding of that and what I understand today, it's really very, very complex. Every food that you eat contains fiber, enzymes, phytonutrients, phytochemicals, and those things play a massive role in your biome to communicate to the rest of your genes. So, at the bottom here, you'll see that I say, you are the only you in you, right? And I really want you to take that to heart. Because if you really analyze what we are looking at, particularly today in genetics and epigenetics, I still have to find a person where I find consistencies in their genetic makeup. So let me just explain to you how we do that. So what we have at the University of Bridgeport, Dr. Diadamo designed a very, very intriguing nutrigenomic program called OOPS23. So any kind of data that you can bring to me from a standard genetic test where you have your genes and your SNPs, like a 23andMe, a health and ancestry version of that, we take all those data points and we upload it into software that then gives us parameters of what's going on in your personal body. The beautiful thing about genetics and genomics is the fact that you never have to do this test again. You understand? You can do tests every week, every day, every year on blood sugar, diabetes, inflammation. This thing you only have to do once. There's so much information in this that if I physically have to print out every page of every paradigm, of every algorithm, it'll be about 10,000 pages of information that will come out of this. Now, clearly we don't dig that deep, right? We look at the person's condition, we look at the symptomology, and then we go dig into whatever algorithm, which I'll speak to you about in a couple of minutes, to determine exactly what's going on there. And once again, I think all of this will make a lot of sense when you guys see the sample case study and what I found in that person's genes. And I'm going to go deep into that condition because I think it's a very undiagnosed condition in the United States of America currently as far as obesity is concerned. Just so you understand the epigenetic versus genetic thing. So your genes are your genes, they can't change. Okay? You cannot change what your genes are doing. But what you can change is what you do with your epigene. So understand what an epigene is. An epigene is the environment around the gene, okay? And the things that activate and deactivate that particular gene. And the things that activate and deactivate genes, guess what they are? It's not just food. It's also chemicals, petrochemicals, persistent organic pollutants, xylene byproducts, methanol in the form of artificial sweeteners. Tremendous amount of things can actually express the gene different. Your environment, toxins, that stuff can all be important. Mold could be a massive trigger to what the epigenetic expression to the gene does, right? So what's interesting also about the software that we use to analyze this information is that it's always going to tell me what I can do in the literature and scientific data today, because we have students consistently doing research on this every day. And this thing is consistently uploaded, you understand? So research that was published yesterday on a VDR receptor or vitamin D or MTFHR immediately gets uploaded into our data portal. So when we look at a particular case, we know the latest updated research that backs up that this particular nutrient intervention shuts down this particular gene. And sometimes you obviously want to switch a gene on, right? And sometimes you want to switch the gene off. And what we find most of the time is that when you go through standard genetics and you see that that person is eating according to what their genes are saying, they're exercising according to what the genes are saying, that person is actually going to not activate most of the oncogenes and the other terrible genes in the system, unless they're massively exposed to toxins and persistent organic pollutants and things like that. We all are. I mean, just sitting in this room, we're clearly exposed to certain chemicals. But the beautiful thing about the human body is it's always there to help you, and it's always there to try and detoxify your system as best as possible. Right, so here is what I want to spend a couple of minutes on. This is pretty much what you'll be looking at when you come into one of these appointments with us. So what do we require from you? We basically require from you to come into my office with a zip file from your 23andMe test or any other genetic test that you've done where you have data points of your SNPs and your genes. We feed that into the software, and it gives us these algorithms. There's more than this, but let's just go through it. We go through classic genetics, neurological diseases, mind-body, methylation, autoimmune and inflammation, diet and lifestyle, digestion, female health. This is clearly a female, because there's no male, right? Aging-related, endocrine-related, hereditary, metabolic, oncology, cardiology, musculoskeletal, resistance and immunity. Then we also have a pharmacological part where we can actually determine what drugs do not work in your body. And which is fascinating about that, nowadays, when a client comes to me, I can physically tell them and print out for the medical doctor and say, this gene is not going to work with this drug, in specific, if you're talking about a certain chemotherapy, or certain medication. So there's really information here that's valuable to the physician, because I'm kind of tired of the period of time that people tell me, well, diabetes is genetic, or weight gain is genetic. Now let's really see if it is, right? Because if it is, then we can figure out what we can do to kind of fix it, but or prevent the gene from being overexpressed. But this whole thing that diabetes is genetic and weight gain is genetic in this country is absurd. Okay, no disrespect to any medical doctor in the room, but you cannot tell me that all of a sudden we've gone from 200 years ago, 1 in 50 people with diabetes to 1 in 3 now. There's not enough time for that gene to evolve to become so destructive in our environment. You understand? I mean, this is an epigenetic trigger here. These are things that we've put into our system and our society that has triggered this massive epidemic of all these chronic diseases that we have currently. So none of these chronic diseases, I feel, are correlated to genetics as much as they are to epigenetics that are expressing the gene, right? And what can you do to switch that off? And just having been in this field for as long as I have, seen the miracles that I've seen in clinical practice, I really understand now that we basically, not knowing what we were doing, even though we thought we were basically switching off some genes. You know what I mean? So I could physically tell you whether you should be on a ketogenic diet. I could physically tell you whether you should be on a high carbohydrate diet. Because like, oh my God, I believe me on a high carbohydrate diet. Yeah, actually there are people that can handle it, but it depends what you define as a carbohydrate, right? Fruits are carbohydrates, yeah.
How do you get to this whole profile? Is it a blood test? Or?
No, it's a saliva test. It's a straight DNA test. So if you send a kid to 23andMe, you do a little saliva swab. Okay. And then that information is sent to whatever labs they do. And then, because we're not associated with 23andMe, we're just looking for the data points, do you understand? Then we upload the data points into the software that Dr. Diadama's research and work at the University of Bridgeport is all about. And this is telling us. So what this makes us look like really smart genetic experts, which we're not, right? We're clinical nutritionists that really understand the biochemical pathways. We understand the physiology of the human body. I mean, we're pretty well trained in the field of medicine, but we're not genetic experts. I don't memorize all these genes, trust me, because that's insane. You have to be a person sitting in a basement with 5 pens to do this stuff. But what I can do is associatively tell you that this pathway is affecting this pathway. In order to stop this pathway from being overstimulated or understimulated, we need to put a block on it. So basically, you send a kit in, they send you a zip file. That zip file would be meaningless because if you click on it, it's just going to have thousands and thousands of data points. And those data points are fed into these algorithms. And these algorithms, if you can see, you have a green and an orange, right? And then we have a gray and a black. So green is what you now will perceive as your good genes, right? So if I click on that, it's going to show me all the genes that are really optimal in your system. So that's cool. But we also want to know that we're not abusing, those particular genes, just taking them for granted, right? Because I smoked for 40 years, so I didn't get lung cancer, so I guess I must be genetically not predisposed to get lung cancer. There might be other reasons that you didn't get lung cancer. You might have had high antioxidant levels or something else. It might not mean that genetically you have strong lungs, right? There's other things involved, because it drives me insane when people, and this is what I find sometimes, even at medical schools, and I respect medical doctors, I work with them, okay? Please don't get the wrong idea. But what I normally see is this dissection of the human body. We have an endocrine system, and we have a renal system, and we have a kind of semi. You eat, you poop, you pee, right? I mean, it's not like you take something out to go do this. It's interconnected. And that interconnectedness and that communication on the cellular level, on the epithelial cells, all the way from your nose, all the way through to your anus, from the enteric nervous system to your brain, through the gut-brain barrier, there's just consistent communication. And what happens generally when these genes are getting messed up is they lose communication. So it's like a cell tower that loses a signal.
at some point. And then that cell tower starts panicking and it starts producing its own cells to protect itself, because cells are designed to survive, right? And that's how you eventually end up with some sort of a cancer potentially. So the orange would be the bad genes, the gray would be non-relevant, and the black is actually not associated with you. So the only things that we would be looking at really would be the orange and the green ones. And I still have to meet a person that I can look at that has exactly the same parameters. It's impossible, right? Because you're coming from two different people. The genetic makeup is in two different categories. And these kinds of things will tell us a lot. For instance, the diet and lifestyle division, this particular topic will tell me everything about what form of exercise you should do. Now, I've been guilty of recommending to most of my patients to do high-intensity interval training, because that's what I find to be the most successful thing for weight loss, right? Because weight loss is kind of like one of my gifts. And some people shouldn't be doing high-intensity interval. It actually stresses their adrenal systems more than others. Some people do better with aerobic training. See, I didn't look at that initially, right? Some people would really do well. I'll give you a perfect example. I recently worked with a patient. He's a kind of a very active athlete, long-distance marathon runner. And he came to me with severely low testosterone, very fatigued, and reasonable muscle atrophy for a person that's as active as he is. So we dug deep into his case, and we discovered that he's been on a ketogenic diet for 3 years, because the ketogenic diet gets you into ketosis, and ketosis gets the fatty acids to burn. And fatty acids are more powerful ATP producers, so it makes sense. Okay, but in his particular case, when we look at his genetic makeup, it's clear that he shouldn't be on a ketogenic diet. He shouldn't be on a high-fat diet. Now, he was on a good quality high-fat diet, make no mistake. Okay, so he was eating fish, he was eating avocados, he was eating leafy greens, not to interrupt the ketogenic to glycolytic pathway issue. But we ended up with a guy that had thyroid dysfunction, muscle atrophy, and low testosterone. So, and he was an endurance athlete, right? He was running long-distance marathons. Looking at the genes, he does better with high-intensity interval training, so he's better as a sprinter. Okay, he's better on low fat, and I'm not a low fat promoter. Don't get me wrong. Okay, I hate the low fat hypothesis, but that's completely different from what we're talking about. So after 3 months of putting this person on a leaner protein, lower fat, and take fat out of the equation completely, changed his training system to high-intensity interval training, he increased his testosterone levels by 400 points. 400 points, including a little bit of intermittent fasting. Right? So we ate good amounts of food. So we ate like an athlete when we trained like an athlete, because I think that's generally a big problem with most people. Most females that want to lose weight, they eat like dieters and train like athletes and wonder why they mess their thyroids. Right? And this kind of testing will also tell us exactly where you need to be in that category. So if we go to autoimmune and inflammatory conditions, this can show us the risk of certain autoimmune conditions like multiple sclerosis. If you want to call Alzheimer's or something like that an autoimmune condition, because the body doesn't tau protein to the brain, you could. But this tells us a little bit about your risks for diabetes, right? And are you at risk for obesity and those particular things. So neurological, we can go into how is your body converting amino acids to neurotransmitters. We can actually pick up in these particular tests if you are, let's say, depressed or you are anxious. Is there something going on potentially genetically with your ability to convert what we call aromatic amino acids to neurotransmitters, which is tyrosine and tryptophan and phenylalanine to convert to dopamine and serotonin. And there are many, many steps involved. So let me just give you a perfect example of that. So let's say a person has a problem with converting aromatic amino acids because of the gene. Right, so they lower, let's say, tryptophan. So tryptophan converts to melatonin. Melatonin helps you sleep, right? So tryptophan is also converting to serotonin. Serotonin is you're happy and you're craving again. So let's say a person craves all the time, they don't sleep. But we can determine that they're taking a lot of these aromatic amino acids into their diet. That means that there might be something wrong with their digestion. Or we can give them the intermediates genetically that they're lacking to pull these nutrients across these pathways that they're not getting. Does that make sense? Because if I convert tryptophan, let me just give you an example, right? So tryptophan, I'm sure you guys know about it because everybody believes that the tryptophan in turkey is what makes you sleepy at Thanksgiving. Let me help you out. That's actually not the reason. The reason is because you're drinking wine and eating potatoes and eating pumpkin pie. That's your blood sugar is out of control and that crashes. That's why you're sleeping, not the tryptophan. because for tryptophan to work well, you actually need proper blood sugar insulin regulation. 80% of this country doesn't do that very well. Okay, so number one, you cannot convert that tryptophan molecule to the blood-brain barrier because of the fact that you're not, because insulin is the molecule that carries it. You guys have heard of something called insulin resistance? So when people have become insulin resistant and they become, blood sugar dysregulated, this insulin is not working well. So one of these amino acids cannot get into the blood-brain barrier properly. All right, now, let's say it gets into the blood-brain barrier. Then it needs to convert to 5-HT, and then it needs to convert to serotonin. For those steps, we require vitamin B6. And what we're seeing today in further testing with people is that many people are deficient in vitamin B6, contrary to the belief that everybody says, no, it's very, very hard for humans to be deficient in vitamin 6. We actually have the clinical data to support this through testing that we're looking at, consistently with B6. So let's say you have B6 and you're converting it to serotonin, and the next couple of steps to convert that to melatonin is a requirement of vitamin C. Shall I tell you that 25% of the population of the United States of America is currently borderline scurvy? Borderline scurvy. I mean, that's crazy. That's the disease that people used to get on ships because they didn't eat limes, right? So, yeah, where do people get the vitamin C from? Nobody's eating fruits and vegetables, right? They're eating a tremendous amount of processed foods, so they're not getting the vitamin C from it. So what I've just told you is that we can determine in that genetic pathway if you have a variant to convert B6. So I need to give you more B6 and the right kind of B6. Like the assimilated potentially B6, the methylated form if you have an MPFHR gene, which all these things are explained to you on a more layman's terms, right? Because that's what we need as clinical nutritionists. We don't need to sit there and look impressive because we can tell you what a VDR receptor is. That's for the really sharp people in the world. My job is to take your genes and tell you what you should eat, not eat, exercise, and what supplements you should take at a higher dose because your body genetically is designed not to convert them. You understand? That's my job. And when I give you all that stuff, you'll see improvement in most cases. Look, we have 5 to 7% cases that are very difficult and they take a lot of time. And thank God for the patience in some of the patients that they stick through it. Generally, we figure it out over time. Yeah, this is not really complicated, is it? Okay, so this is just one of the algorithms of the pathways that we can look into, right? So let's say I want to look at this particular algorithm, and let's say this algorithm is related to energy metabolism, right? Can you see that I can see orange and yellow and all the other ones in white? The ones in white not affecting me. I need to just go into the orange and the yellow. And for a layman's term, the orange is kind of really where I want to start, and then work my way back to the yellow because we have heterozygous and homozygous associations with these particular things. So if I click on this puppy, right, it brings up a screen. It tells me about this particular gene, what gene is associated with, what nutritional associations and diseases are associated with this particular gene, and how that overlaps with all these other genes. Then I can click further and it can say to me the latest research that we have, this is an agonist or an antagonist to this particular gene, so it switches it on or off, and this is what the literature is supporting. So let's say curcumin switches this one off, and you don't want it switched off, then clearly that person shouldn't be eating curcumin, they shouldn't be taking a curcumin supplement. That's how deep we can go with this stuff currently. And when you go that deep, now you're really talking about personalized medicine or personalized nutrition, or whatever you want to call it for the first time. Because this is overlapping the medical field. This is not just the hoopla holistic nutritionist on this side that's cooking herbs on the side of the road versus the medical doctor that walks around with a big stethoscope and looks all smart. This is actually overlapping the entire industry. And it's fascinating because why I was asked to speak at Georgetown initially just as a guest lecturer, because the students were starting to ask, why don't we have nutritional functional medicine in our curriculum? And two, at Georgetown they have a massive hospital on site there. The patients are starting to ask, why the hell am I in the onco ward here and you feeding me McDonald's from downstairs? So patients are starting to get a little peed off, right? And rightfully so. I mean, you guys should say, hey, wait a minute. This doesn't make any freaking sense. Why I cannot understand why I'm not being fed proper food. Right? I'm not saying they have McDonald's at the bottom of Georgetown, but I've seen some of the food's not the best. right? So that's kind of where they want to, trust me, it's slow steps. But we are breaking that mold. So I take you through all these in a period of 2 or 3 appointments and really tell you where you need to be. The beautiful thing about this is Dr. Diadama and his team has also designed this to the point where we can give you a layman's explanation of each one of these things. So we can click on patient document, which will explain it in layman information. And most of the time I read that more than I read the other thing, trust me, because it makes more sense than the other side. You can go to the next one. Right, so what I want to talk to you guys about right now is a perfect case study on the patient that I'm working with. And this will give you a really good understanding of where I'm going with this. Lipedema, are any of you familiar with this condition? You are, okay. It's coming to the forefront now. It's officially only been diagnosed since 2011 in medical literature. Many medical doctors are familiar with lymphedema, right? Which is normally unilateral, meaning that it's only affecting one side, either when you've had the lymph nodes removed or something to that effect. Lipedema is the modern face of obesity in this country. And I'll tell you why I'm saying it. You can't tell me that you haven't been to a mall or a supermarket or a store or a Walmart or a Target store when you haven't seen a person like this walking around or riding one of those little cars, right? And automatically, the first thought in our heads is, oh my God, that person is overeating or they're doing. Let me give you a little piece of information, okay? Some of these patients that I'm working with now, this is really becoming my area of digging down the rabbit hole right now, right? Some of these patients are eating 500 calories a day and gaining 3 pounds a month. Okay, so clearly this is not calories in and calories out, right? So what happened was in 2000, and what is it now, 2018? In 2015 or 16, I published a paper on a hypothesis. And I said, lipedema is the modern face of obesity. If you go Google it, you'll probably find the paper. And what I said in there is I said that we are barking up the wrong tree for this whole epidemic of weight loss resistance by looking at specific diets or whatever. For instance, I'll give you a perfect example. If you put a lipedema patient on a ketogenic diet, even if it's the healthiest version of it, they'll gain about 20 pounds. Okay, so that's a big mistake. You can't put them on a high carbohydrate or high fat diet. You'll see some of the genes that we're looking at the moment to try and figure this out. But to make a long story short, I wrote this paper and somehow this really wonderful lady ended up in my office, right? And she has lipedema. She has stage 2 lipedema. There's various stages of it, right? And she said to me, listen, I read your paper and I've given it to 1 or 2 of my doctor friends and they all agree that this hypothesis makes sense. I would like to be your guinea pig, to take your hypothesis into an intervention and go further. Before I know it, I had 12 lipedema patients in my office. These people are desperate for help, right? And we only now start to figure out. Now, I'm one of those people, as I designed a diet for diabetes reversal, which has been very, very, very successful. Type 2 diabetes, I'm talking juvenile. Metabolic syndrome, we reverse it consistently in our office, which is hyperlipidemia, hypertriglyceridemia, dysglycemia, things to that effect, which means high triglycerides, high lipids, cholesterol, and high blood sugar. But these people are, number one, the 12 people that I have right now working with, they're all the most compliant human beings that I've ever seen. They will do anything to try and prevent this from going any further. Now, I don't know how many of you can agree or disagree with it, but if you don't think that you're seeing a lot of this out there, in the lipedema associations or these chat groups or organizations that they are a part of, will tell you that they think that 35% of the population of America currently suffers from lipedema, and they're not diagnosed as such. These people do not do well on low-calorie diets. They do not do well on low-fat diets. They do better on low-fat diets, but it has to be phytonutrient-based. Now, here's my hypothesis and what I came up with. I believe that this is actually a permeable lymphatic system. You guys know that you have permeability of leaky gut, right, that we've spoken about. They're tapping that in the medical literature right now. It's possible that you can actually have that. And just so that you know, lymph fluid feeds fat cells 4 times more aggressively than anything else. If you take lymph fluid and put it on fat cells, it will multiply. So what we're seeing in these patients is not only hypertrophic fat cell development, which means that the fat cells get bigger, they also have hyperplastic fat cell development, which starts producing more fat cells. And that's not really something that you should be doing at that particular age. So let's go to the next page. So here are the levels of it. And I started my hypothesis paper way back because one of my patients was a cyclist, and she was fit, eating right, and she started to develop lipedema, from the waist down, because that's kind of where it starts. And she couldn't understand, so she physically had the look of those days. The upper body was in shape, and then it starts going down, and then it starts going up. And you can see that your next stage looks like this, and then you get to stage 3, and then you get to a stage which they call, sits on hard word you want to express, called elephantiasis, where really you can get the bottom parts of the ankles looking very similar to what an elephant legs look like. You can't see anything, but it never affects the foot. It's unbelievable, right? It's completely lipedemic because you don't have a lot of fat in your foot as a general rule. So this is clearly some sort of a genetic issue with this. So what I'm going to do right now, go to the next slide for me. I'm just going to go through some of the really complicated stuff that we look at, okay? But I'm going to read through this, I'm going to explain to you pretty much what that means. But this is the stuff that I have found in every single one of the 12 patients. Every single one of them, genetically. So there's 4 or 5 points here. You'll see that all of them came up with a VDR receptor. Now this is the location of this particular gene, if you want to know. And if you see here, the targets of the vitamin D receptor, the VDR, are principally involved with mineral metabolism through the receptor, regulates a wide variety of other metabolic pathways by expression and repression of many genes. Examples of those are involved the immune system response of thyroiditis, diabetes by modulating CD4 lymphocytes, the autoimmune activity of Th1, which is the balance of your innate and standard immune system by reducing the production of interleukin-2. So what this basically means to me is that this particular gene could upregulate a tremendous amount of inflammatory cytokines. So when these people are exposed to the wrong things at the wrong time, they are more susceptible to inflammatory reactors. And do you understand that if I'm not going to do this, I'm saying, let's pretend that I'm going to punch you in your eye, right? If somebody punches you in your eye, what's the first thing that happens to your eye? It swells up. Because it has to swell up before it can get better, correct? What do you think that swelling is in the eye? Is that water or not? There's water, there's macrophages, there's all sorts of immune modulators inside of it. So what if I keep punching in your eye all the time? Is it ever going to heal? No, you're going to form calluses and it's going to stay swollen, etc., etc. So how's that any different internally? What if I have something in your body that's keeping punching you and never healing? You follow? So these people's VDR receptors aren't working properly. Go to the next one. So here's something called the SALT2A1, and this is a sulfotransferase family. It's a cytosolic enzyme. And what this thing is to do with is the detoxification of compounds such as thyroid and adrenal hormones. Now I can tell you already that anybody that has inhibiting thyroid function is going to have weight loss resistance, correct? And people with adrenal issues are generally going to have weight loss resistance. So if you look at these particular genes, we can start looking at the associations and the things that could potentially switch these genes on and off. Where the literature is starting to lead us is most of these things are related to nutrients. These people are lacking certain nutrients or enzymes or metabolic steps to get to the next stage. Let's go. This one is fascinating. I looked at the literature since 1974, and the first time this disease was mentioned in medical literature was something called painful fat syndrome in 1974. When you touch the fat on these people's legs, it feels like a beanie baby. Very interesting, and it's sometimes extremely sensitive. Why? Because of those genes that we spoke about causing all that inflammatory reaction, that inflammation. It's painful when you touch an eye after it's been hit, right? So it's the same thing there. It's very, very, very painful. Now, anybody with lipedema has a 4-fold increase of vascular endothelial growth factor. 4-fold increase. So I can tell you right now, everybody, this should be the diagnostic criteria potentially of this condition, and I put that in my hypothesis paper. So, vascular endothelial growth factor encodes a protein that's responsible for increasing blood vessel permeability, stimulating new blood vessel growth, promoting cell migration, and inhibiting cell death, which would mean that these people don't shut down the production of these cells. You understand? Now we need to figure out exactly what we can do to inhibit that. Now do I have the answers on that? No. Yet, no. But I have a team of graduate students at 3 universities currently working on this with me, and we're hopefully going to have some baseline protocol to be able to put into action with these patients that want to do it in the next couple of years. But what I'm saying is that I couldn't get to the bottom of lipedema without looking at the genetics and the components of genetics. One more. TNF, this is a tumor necrosis factor. This gene encodes a pro-inflammatory protein that is mainly secreted by macrophages. And what we find with these people is that there's a macrophage that gets into these fat cells and starts eating away at the inflammation at this, because macrophages are your Pac-Man, right? And you go in there to kind of double away at this stuff. And that causes more problems because macrophages are supposed to go in and out, and these things are consistently overstimulated. So there's another inflammatory, pro-inflammatory protein that is produced. I think that's it. Is that it, right?
That's it.
Okay. So I know at 45, that's pretty close.
Yeah,
right?
so we have about 10 minutes for questions.
Yeah, so I just wanted to conclude by saying that there's many more. These are the ones that I found in all 12 patients. So I'm going to run now probably another 20 or 30 patients, because before I publish the next paper or design an intervention protocol for this in any way, shape, or form, I need to know the consistent genetic association. But it's fascinating that in 12 people with the same condition, you can have a consistent genetic modulators. And there's another one called the LDL receptor, by the way. I didn't put it on here because it's a very long explanation. And the LDL receptor is how your body takes up cholesterol in the liver and uses cholesterol, for other components. So we find that there's an issue with that receptor. What we're going to do with all this information at this particular point, I'm not sure yet, but there's certainly enough information out there that we can figure out what we can do to help upregulate and stop some of these particular things. And I'll tell you what, the answer probably, because of it's so multifactorial, and it has so many different divisions in the genome, it's probably not going to be a drug. You know what I mean? It has to be more multifactorial and lifestyle. So at least for these people now, like this one patient that came to me, flat out, she can't be on a high-fat diet, and she's been following a ketogenic diet. Because that's the new thing now if you go into the lipedema website. And that's what I always tell my students. You want the answers to a condition. Don't go to the literature. Go to the patients that have a condition and see what they do to improve their condition. And then dig into that information, because that's where you're going to find the answer. Because these people have tried everything, right? So why do you want to go and search more? And sometimes these people do things that work. Now, with a clinical brain, you might be able to figure out why it works. They're just doing it because somebody told them, and somebody told them, and somebody told them. But there's a lot of good information that comes from it. So that's it. So, I mean, that was just an example of what we're doing with this particular information. You're clearly not potentially going to go at this level, but if you do any kind of genetic assessment in the nutritional division, we'll be able to tell you what supplements, vitamins, minerals you need to take, probably at what dose, what diet you should be on, what exercise factors you should be involved with, and we can even go as far as probably what levels of de-stress you should be. It's pretty fascinating because it's an evolving science. It's amazing. Now, one more thing: if you add the gut biome information to this equation, it's going to get pretty interesting. Right? Do you guys have any questions?
Who pays for this? Does health insurance cover, or is it all privately paid?
Yeah, there are certain conditions that you come into our office with that would be nutritionally based. So let's say you're in a metabolic syndrome category or some sort of nutritional association, pre-diabetes or weight loss resistance or something like blood pressure. Yeah, then you can associate that visit to the intervention of that. But no, the insurance company is not going to pay for you to do a 23andMe test and then do an evaluation on genetics.
So what's the cost?
You're looking at about $130, I think, to do the 23andMe test. Sometimes they have specials going on. And you have to do the genetic and ancestry. Not just the ancestry. You have to have all the data. And then it's an offered visit for us. It's probably going to run you around $200. And then you get a full report. And consistently, that information is available to you whenever you want it. Obviously, if you go see a doctor, if you have to go on medication, it's as simple as what's my genes say about that. And what I nowadays do also is with the genetic information, which clearly you understand that right now, I'd like most of my patients to do this because it's a one-shot deal. You know, so if you get diagnosed with something, I don't need it anymore. If you get diagnosed with something 4 or 5 years from now, you know, we can dig into those pathways. But I clearly go through all the algorithms and tell you what your risk factors are. And many times you'll find that your aunt had multiple sclerosis and your dad had lung cancer, and those genes aren't there. You know what I mean? So then you can kind of safely assume that you're not saying you can't get the disease. Please understand that. If it says that you have a low risk for dementia, doesn't mean that you can't get dementia, right? Because there's environmental factors that can trigger that gene, even if it's a good gene for you, know, to be up or down there. So that's where the toxins and the detoxification pathways and the proper absorption of nutrients come in. Just
You mentioned the gut bio information also. How is that done and where do you do that?
There is now a new gut biome association that you can do through some of these labs that we are working on uploading it into the data as well, but that's clearly also associated with some sort of a stool test. So there's some stool testing that you can do that we can take those data points and feed it into the software of Opus 23. I would say to you that we probably January, February, or March away at the University of Pittsburgh to actually launch that platform. So if you've done a GI-FX test on the Nova Labs or whatever, and you have some of those markers in there, that stuff's uploaded. So we're basically going to get to the point where you can bring all your functional tests to us and upload it into the information. But that's all Dr. Diadamo stuff. Question? Yeah.
So I understand insurance won't cover it, but insurance likes this kind of information. How is privacy maintained, or can it be maintained?
Okay, well, the whole thing that you're talking about, 23andMe, was the whole privacy thing that was invaded, right? Is that what you're referring to?
Yeah, well, just in general, just once it's out there, or it's done, how is...
Well, obviously, you know, that would be a super HIPAA violation.
And not used against, and that, you know, how insurance companies, I don't know what's happening.
You know, all I know is that that whole thing with 23andMe has been settled, right? And they obviously got, you know, reprimanded for that. But they didn't sell personal information, they sold data point information. They didn't sell the person's individual information. They basically said that of the 28,000 people that we tested between these age groups of this group of ethnic background, they had these genes. And they sold those to pharma companies, right? So that was clearly corruption and bad news.
Well, I'm really going more to the point of, you know, you'd like to try and get some insurance coverage if you can, but then does it mean they have the right to this information that maybe you don't want?
I hope not.
I don't know.
No,
I think it's great information, but...
Yeah, but I mean, you know, they can do that with any of your information really then, right? You know, this is just a test. This is just an evaluation test. It's nothing more than, you know, it's obviously more in depth than any blood work that you can do, but, you know, what's the accessibility to those people to the blood work that you take? It'll be the same. It'll be the same here. None of this information is fed out to anybody, other than the information that I shared with you with 12 patients that I've used, and this is what's come up. Because that's why we're doing that, you know, to collect the data. Yeah?
Do you work with children?
Sure, sure. I work with humans. Anybody with a genome, you know, you could certainly have that. You know, it's fascinating because I'm trying to kind of dig a little bit into this whole autism thing as well. And what we find is not specifically necessarily gene stuff, although they all have sulfation issues, means part of the detoxification pathways, all of the inhibitors, but stool testing. What we've seen is consistent overgrowth of species called Clostridium species. And we find in the gene pool with them, I'm not being, I've only done maybe 7, we find that they do not absorb fatty acids very well. And that's 2 common denominators. Now clearly the brain is massively reliant on fatty acids, your cell membranes are massively reliant on fatty acids, and they seem to all have a carnitine deficiency, which is an amino acid that helps to catalyze fatty acids inside the cell. And they all have this Clostridium species overgrowth. And I don't know if any of you went to listen to the talk this morning about the glyphosate thing. You know, glyphosate is the herbicide that we spray on everything because we think it's a good idea. That particular herbicide actually destroys all bacteria in your gut like an antibiotic except Clostridium. Clostridium species can grow without being destroyed by glyphosate. And that's definitely something I will tell you. You want to talk about an epigenetic trigger that causes a lot of trouble in our world? That organophosphate is dangerous. That is bad news. Somebody else had that. Yes.
I just wondered, do you also work with genetic testing, BRCA1 and 2?
Sure.
uterine
That'll show up.
cancers, all of those?
That will show up. That definitely
That's
show
also
up.
something you work with the
Sure. I mean, you know, when you get to the BRCA testing, right, when you get to the estrogen-sensitive cancers, you know, what we've seen in the literature in nutritional medicine is that if a person is taking in huge amounts of chloroquine indocarbonyl food, right, DMN, which is the byproduct of spurous vegetable, you can actually negate some of those risks. And that's been shown clinically. You know, there's pre and post testing that you can look on. We get a little technical here. There's something called 2,6-hydroxyestrogen, which we can do the measure of the good and the bad estrogen. And if you physically eat those foods, you can shift that stat, even with a BRCA.
even with your testing coming positive.
Yeah, so I would say that if you have the gene, I would definitely stimulate more of that lifestyle and those particular foods to regulate the balance than a person that doesn't have it. But the BRCA gene shows up. Yeah, because it's just part of genetic makeup. Yeah.
I would assume that you're able to reverse problems with IBS and colitis nutritionally in a lot of people.
Yeah, all these chronic, before you go any further, so let me answer the first part, right? So IBS, without a question of a doubt, we're probably the only people in the industry that really focuses on really what's the cause is. You know what I mean? So yeah, I'm actually working with an IBS protocol right now that I designed. But it actually ties very much into this, and it gets back to the intestinal permeability. Because I think IBS is really just intestinal permeability. Like this whole thing that you guys go to a doctor and they do an IgG test for food allergies and you have 60 food allergies. Nobody is allergic to 60 foods, okay? That's not humanly possible. What is humanly possible is for you to eat the food, and because you have this problem with your gut, some of these food particles get into your system unbroken down and your immune system gets a little upset. So this week you're allergic to garlic and beef and chicken and food. Nobody is truly allergic to that. It's not an anaphylactic. And I made those mistakes because when I came out in this industry, I tested everybody for IgG. That was a big thing in 2005 and 2004. And really, I would see people with 27 food allergies. So the thing was, okay, well, just don't eat those foods. That's crazy, right? Because not eating those foods is taking away some of the most nutrient-dense things that you need. So what you need to figure out is, how do you get the immune system not to be so overactive? And it's not just eliminating the food. And for IBS, for instance, there's a diet called the FODMAP diet. I'm sure you've heard of that, right? So the FODMAP diet has been shown to really improve small intestinal bowel overgrowth. But it eliminates like a ton of really good food. So the job is to put a person on that diet, improve it, and then reintroduce the food. So you know that you're working well with that person, and you can give them the food that they used to react to. In the whole food family. I'm not talking about processed cereals. No human on the planet is really designed to eat that stuff. A little bit here and there, not a big deal, but we're really not supposed to be eating it. Yes?
Are you able to evaluate any environmental factors too?
Not specifically in the genetic test, but there are tests that you can look at, like organic acid test, where we can tell you exactly what exposures there have been in your system, because it actually tests a couple of the genetic associations to detoxification pathway. So we can determine if there's a petroleum toxicity in your system or if there's a organic pollutant issue in your. So you can do it through different testing. However, the genetic test will tell me how well your pathways clear those things. So let's say you genetically don't have it, but you're showing up in the organic acid test as such, then I know that you have a serious problem because your system actually detoxifies things well. So then you know that you have a tremendous buildup. So there's a little bit of a back and forth. Remember, this is not a diagnostic condition-associated test. This is your fingerprint, right? And your fingerprint is telling me that you've not been arrested before. Really, that's what it's telling me. It's telling me everything about you. Now I need to look at your lifestyle factors. Now I need to look at your diet. I need to look at your symptomology and see if any of that is being upregulated by what you do. So let's say that looks really complex, then I might recommend an organic acid test to determine where some of those toxicities are. So there's a couple of tests generally, the genetic testing, organic acid testing, and stool testing. Those three, if I'm working with really complicated cases, will tell me just about everything I need to know. You know, as far as what the actual causes of the problem, what's the real deep-rooted cause of the problem. Is it a mold exposure? Because a lot of people don't realize that mold exposure can eventually turn to fungi in the body, because it converts to fungus, when it gets into the system. And not that you should kill all fungus either. Now, getting away from this whole thing that we have to kill the good and bad bacteria, there's no such thing. There's only homeostasis. You're supposed to have clostridium species in your body. You're supposed to have H. pylori in your body. You're supposed to have fungus in your body. Understand that? You're supposed to have parasites. That's how the body balances itself out. So we now go in and give people an antifungal diet to kill all the fungus. Now we wonder why the bacteria starts to overgrow. Okay? Or the alternative to that is now all of a sudden the limes kicks in more aggressively, because that's a bacteria. Why? Because you're killing the mediators of balance. And that's the problem, right? With some of the exogenous toxins that we're taking into our body is killing a tremendous amount of these bacteria in our system, good and bad. And that imbalances where the problem lies. For instance, in your stomach, you're supposed to have yeast, streptococcus, H. pylori, and lactobacillus. Now, only one of those things sound good, right? Fungus sounds bad, yeast. Streptococcus sounds really bad, like strep throat. And H. pylori, oh my God, that's the worst. Right? Can't have and here's a fascinating thing for you. We just had a patient in our office. You can reverse H. pylori in a very short amount of time by giving a person Manuka honey. 1 to 2 teaspoons a day. And you will physically bring that H. pylori down. You know why? Because the H. pylori contains lactobacilli. So you're putting the bacteria back in that's missing from the other one to overgrow. Don't go and just kill the other bacteria. That's insane. Manuka honey. Manuka honey. Manuka, M-A-N-U-K-A. Manuka honey. All right. I don't go just eat tons of Manuka honey. If you have an H. pylori overgrowth, because if you don't have an H. pylori overgrowth, you might put too much lactobacilli. And this is the final thing I want to say. Be careful to get on this bandwagon and we're just pumping ourselves full of probiotics as well. Okay, these are very smart little critters, okay? And overstimulation of the good, I don't think is the answer. I really don't think it's the answer. You need to, and maybe that's a lecture for a different day, but there is what I believe a fingerprint that you are born with after birth, about 300-400 days into your life, that your body is trying to go back to the rest. And the literature supports. Cool. Any other questions?
You actually have to have a problem to come to the office.
Everybody has a problem. No. But that's a great question, actually. What's wrong with trying to maintain optimal health, right? What's wrong with inflammation? Absolutely. No. I encourage that because that's the best form of preventative medicine in the world, isn't it? When you come to me when you're healthy, we can look at your blood work when you're healthy. We can look at your genes when you're healthy. We can look at your organic acids. Then we know what the baseline is, and then we can find if there's certain blockages. Well, thank you for your time.
Thank you.